Hello everyone, welcome to VoltNet. Today I'm going to present how a surrogate graph neural network model can dramatically speed up optimal power flow. It calculates and helps the grid safely utilize more renewable energy like solar and the wind. Now the question pops up, why renewable makes the grid complicated? So let's answer this question. Renewable energy is clean, but it is also very unpredictable. Solar fluctuates when clouds pass, wind changes minute to minute, demand also fluctuates throughout the day. So every few minutes, the power grid must ask a very important question. Given the current sun, wind, and demand, who should generate how much power and how should electricity safely flow through the network? And this calculation is called optimal power flow. The problem is OPF is very heavy. It takes seconds or minutes, while renewable changes very quickly. And this mismatch creates instability. Your OPF basically is a huge math optimization problem. Traditionally, engineers solve OPF by running nonlinear power flow equations. These equations work very well, but they're extremely slow when repeated thousands of times per hour. Okay, so now I'm pretty sure you guys must have gotten a good background info. So now let's look into the AI stimulation page. So on this AI stimulation page, you can set your own conditions using these simple sliders here. So your renewable percentage tells how much energy that comes from the solar or the wind. Then we get to see battery state of charge. Here it of course shows us how full the battery storage is. Then the load factor tells how much electricity people are using compared to the normal. And the baseline index is a reference set up for comparison here. So here when I hit run AI predictions, VoltNet stimulates the grid in real time. It also predicts voltage levels, power flows, curtailments, and how batteries should charge or discharge to keep things stable. For example, if a wind farm suddenly drops from 200 megawatts to 120 megawatts, and this is pretty common, VoltNet here instantly recalculates the grid balance, showing how other sources can adjust to prevent instability. Okay, so now let's quickly dive into the dashboard page. So the dashboard gives you a quick visual summary of what's happening in the grid. So here you can see the average voltage that tells you how stable the grid is. Power flow shows where energy is moving between the nodes, and curtailment is how much renewable energy had to be reduced. And then grid nodes tells the total points in the network. So it also includes graphs that make the data very easy to understand, like the voltage profile graph. Here it shows how voltage changes across different areas. Smoother lines means a stable grid. The power flow graph shows how much power each node is sending or receiving, helping identify overloads or weak spots. Okay, so now let's look how the surrogate GNN works. So instead of solving actual power flow equations every time, which is quite slow, the surrogate GNN learns to mimic the OPF solver. We give it input features like load at every node, renewable generation at every node, battery status, line parameters, and GNN predicts the node voltages, power injections, line flows, angle differences, etc. etc. So what exactly is the key advantage here? It does all these predictions in literally fraction of seconds. Instead of wasting so much of our time, which was done by classical OPF, it makes it possible to react instantly to renewable fluctuation. And that's exactly what we're trying to do. Our model is not here to replace physics. It's here to speed up things. And let's look into the three main major benefits. First is real-time operation. Example, a solar output drops suddenly. The GNN can instantly estimate new voltages and line flows so the operator can take immediate action. Second is massive scenario testing. A planner may need to test thousands of possible renewable conditions, and traditional OPF is very slow. Then, better use of storage and flexibility. The operator can ask questions like, if I charge the battery now, will voltage stay safe? If I curtail solar here, will line overload or reduce? This allows millions of such tests per hour. So, what exactly is it designed for? Researchers exploring renewable energy integration, utility companies managing smart grids, and of course, energy planners and students who want to visualize and test real grid conditions. And this is also very scalable, meaning it can work for anything from a small microgrid to a national power network. As more solar and wind plants are added, WoolNet learns and adapts, giving faster and more accurate predictions over time. So in short, WoolNet replaces slow manual calculations with fast AI-based predictions, helping grids use more renewable energy safely, reduce waste, and stay stable in real time. WoolNet is managing energy smarter. Thank you so much.